Hello guys, let's solve today's Geeks for Geeks problem of a day. Maximum dot products with zero insertions. Okay, two arrays size of m and m. Excuse me. Okay, two arrays of size m and m. Okay, where the first array is the size has less than of size n. Okay, first size will be the less than second array. We're allowed to insert 0 anywhere into the second array so that the length, okay, so that the length will equals to n. Okay, you're allowed to insert 0 in the area of a second array. Okay, so this is very confusing. I always used to think like the first array will has the size of m and then second array will used to have n. Okay, second array you can insert 0, so and then we need to return the maximum product of dot product, like which is the. Okay, so I was thinking like yeah, I agree, like after seeing the constraint I just immediately I thought, okay, yeah, okay, this is a regression. Um, but actually, what I would just say is like, if you are a fresher, like, if you are the new guys into the problem solving, what I would just say is like, if the question is like, okay, so excuse me. So yeah, so actually, if the question is like, if the question is like, insert zeros at any place, like if a question is like insert a zero any place and then you can do any of operation and then return maximum, you can do any number of operation to maximum. The simplest case, if you are not able to just find a solution in a single way, if the solution was not in a straightforward, and we can also say, yeah, if the solution is not a straightforward, the solution is like choosing has a multiple operations or has a multiple tree or multiple decision, then the question is recursion. Then there's only way to solve the question is recursion. Like, yeah. So actually here we can just we can easily have the two index and then we can simply the same. If you have just watched my previous video, I always used to say like all the recursion question has the majority of questions will be like a knapsack algorithm. So the take and not take. So actually here we have two index I and j. So actually we have two options. Either I can just take this current index and then multiply, if let's say if my I was standing over here and then if my j was standing over here, it will just take put it over here so that it would be easy. Okay, so say if my I was here, say if my one of the index was here and then if my one of the index was here, I will always have the two operations. Either I can just take this and then multiply and then I can move forward, or what else I can do, I can just skip it and then I can just skip it and then we skip in the say I was just saying that insert zero in the place. Yeah, take or not take, the simple and straightforward that knapsack algorithm. um, yeah, private end maximum dot product and then pass both the index, pass both the array as well. The first base condition was if my both the index must has to reach the end. If that's the case, I will simply return 0. Okay, if none if either of one is in this position, which means we can, because which means the dot product is not possible, right? So in that case we can just return this is the value, okay, something. So in max product equal to, first I'm just going to do a skip operation, I plus 1, keep the I as same, and then j, skip and then a and b. You guys might think, actually here we are skipping, we are just multiplying with 0, right? Why he is just doing this way, like. So yeah, so here we just skip this and then keep the j as the same, because skipping means we are inserting a 0 over here, and then 0 means like 3 times of 0 was 0, right? So nothing to add, so that's why I say skip. So take the max product as, take the maximum of max product, and then do the actual multiplication, and then add it, and then max, call the recursive function as I paid. I have taken the both the index as well, and then a and b. So return my max product. So pass it, and then yeah. So for the recursion, definitely we need to optimize it, right? So here we go. Optimization, yeah, dp. I'll just pass it a dp of I and save the value first, and then return the cache in memory. But if we already seen this path before that, just initialize these guys. So initialize this guy. Yeah, here we go. Yep, hope you guys understand this. I'll get something up. I'll travel with Praveen. Okay, seems like something is wrong. Testing 68. The possible solution is like 4 times of 8 and then 4 times of 9, I think. Here actually 4 times of 8 was 32, and then 4 times of 9 was 36, which is total of 68, right? Yeah. How come? Okay. Okay, after we are reaching it over here, this condition is full, right? So the only thing is like we can even still go there. If this is the case, we can simply return. So what else we can say, like if j was 0, if only if j was 0, we can simply put 0. What if I was 0? If I was 0, okay, I think this is the condition. This will work. So what this means is, if we encounter j was 0, which means that if we have just reached possess both the elements, and then if our I was still stands in the 7, we can just insert all the zeros over here, and then we can simply return, right? So we can simply return 0 in this case, right? Yeah. So what if I reached 0? If I reached 0 means like here we are not skipping any of index, right? Yeah. So I think this will work. We can just test this one. Simple mistake. Yeah, good. I always used to do some mistakes. Yeah. Okay. Hope you guys. I think I have already solved it. I want to know. 2024, 2 years back, how I did it. Okay, I added some good conditions. Something. Okay, this seems good. Okay. Hope you guys are travel with Praveen. Stay consistent.